Hello guys, this is Alan Paul, UR16CS006, and today we're going to do our fifth experiment in the System Software and Compiler Lab, which is to simulate the concept of single process as single pass assembler for simplified instructional computer. So an assembler is a program that accepts a machine language as input and that accepts as input an assembly language program and produces its machine language equivalent, that is object code, along with the information for the loader. So what an assembler basically does is it takes in the assembly language program as an input, that is the source program as an input, and then it goes on and produces the required machine language equivalent, that is the object code that is required to run the program, along with the information for the loader that it changes an assembly language into a machine language, and along with the information that is needed for the loader. So here we have the experiment that we have. So here we have the necessary input Java IO files and the util files, and then here we have we'll check if the input line has the opcode start to do the following executions. So we'll check if the input line has it. So if we'll find if there is any operand field, then if there is we'll find if there is any operand field, and if there is an operand field, we'll then set LC to 0. Here we'll find the operand field, and then if there is any operand field, we'll put LC to 0. And then if there is no operand field, no value in the operand field, then LC is set. And then if there is no value also, then we'll put LC to 0. LC will be put to 0. Here we have initialized LC to 0. So then we'll write the input to do the line for the intermediate. Then we'll write the intermediate file, input line for the intermediate file, and we'll do the following until the opcode ends. Once you opcode ends, we'll check the symbol table. If the symbol table is not available, then we'll enter the symbols into the symbol table, sim tab, or the symbol table. If the symbol table is not available, then we'll enter the symbol table symbols into the sim tab, or that is the symbol table. And then to find the length of the program, subtract the starting address of the program from the LC. So to find the length of the program, we'll subtract the starting address from the LC. So then we have system.out.print. So we'll check for the labels, and if label already exists, we'll print label already exists, and if a label doesn't exist, we'll just print invalid label name. Then we have the symbols. Then we have the hash table. We'll have the start ready op table, that is hash table op is equal to new hash table 30. So when we run the program, we can see that the program is still running. Sorry for the delay. When the program is run, we can see that we are getting the desired output, that is h copy colon 00100 colon 0000C, and we are getting the address and showing that label already exists and that the build is successful. Thus, we have completed the experiment successfully.